Alright, hi students, welcome back to the second part of the videos on metals chapter. So in this part of the video, we actually focus on just one key questions, which is the question on what are the products formed when metals react with cold water, steam, and hydrochloric acid. So in case you didn't know, we actually can arrange the different types of metals in order of their reactivity, and this is what we know as the reactivity series. So this is something that you have seen before in the chapter on acids and bases, where we talk about how come certain metals can react with acids but other metals cannot, right? So we talk about these mnemonics, the one on popular scientists can make a zoo in the lab, however cannot see ghosts, right? So you can go back and take a look at your notes in case you forgot. So this is a series of metals arranged based on their reactivity, with the one at the top, potassium, being the most reactive, and the one in the bottom, gold, being the least reactive. But how did scientists come about with this? What we do is we actually compare how these metals behave when they were to react with water, steam, as well as hydrochloric acid, and we base on this difference in reactions, we actually rank them in terms of their reactivity. So let's take a look at the first type of reaction. Metals can react with cold water. Not all of them, but some of them can do so. And in cold water in chemistry, we actually refer to water of 25 degrees Celsius, right? And in this reaction, it actually produce two kinds of substance, metal hydroxide as well as hydrogen, right? So these are the two products that comes about. Let's take a look at each of the reaction individually. So let's take a look first at potassium. How does potassium react with cold water? Alright, as you can see in this video, what you realize that this reaction is a very violent reaction, whereby you see the potassium metal, once it's being added in, it actually darts around, there's a lot of smoke coming out, and in fact, if you look closely, there's actually a flame that's being ignited, and the flame actually has a purple glow to it. It's what we call a lilac flame, right? But most importantly, you realize that the potassium metal is still floating on top of the water, which is the characteristics of all group 1 metals, the alkali metals. And now, if you were to add in, say, a universal indicator, then we realize that the indicator actually reflects that the solution is actually an alkaline solution now. Now, why is it an alkaline solution? If you come back and take a look at this equation that we have over here, metal reacts with water to give you metal hydroxide and hydrogen gas. So, for instance, if you have potassium reacting with water, you end up with potassium hydroxide, right? And that itself is an alkaline. So in terms of the reaction of potassium with cold water, we say that it's a very violent reaction. It produces a lilac flame, a purple flame, and of course the metal is actually floating on water because it's actually a group 1 metal characteristic. And in terms of the products that's formed, it actually forms potassium hydroxide, hydrogen gas. Now let's take a look at sodium. As you can see in this video itself, when sodium is added into water, yes, it is still reacting rather violently, but it's not as much as compared to in the case of potassium. Sometimes there can be a small spark of flame being produced, but most of the time the metal is floating and darting around the water surface. In terms of the product form, do you have any idea what is the product that's being formed? If you think about it, sodium with water, and you need to form a metal hydroxide, yes, you form sodium hydroxide. So if you take a look at what happens when the universal indicator is added in, you realize that this time round, it is an alkaline solution that's being formed. So in terms of the reaction of sodium with water, we see that it reacts violently, the metal floats on water, and the products formed are as such. The third one, calcium.
Add the calcium metal to water, we get a much more rapid reaction of the calcium with the water than magnesium. The reaction is very exothermic. This is due to the lower ionization energy of the calcium. We get a single displacement reaction producing hydrogen gas and the formation of slightly soluble calcium hydroxide. We can test for the hydrogen gas by collecting some of the hydrogen gas in a test tube and testing its flammability.
If you take a look at the reaction of calcium with water, if you compare it to the previous two videos, the calcium no longer floats on the water surface because it's not a group 1 metal. So most metals have high density. But in terms of the solution that's being formed, it actually results in the formation of calcium hydroxide and hydrogen gas. Calcium hydroxide is an alkaline, which is actually the lime water that you use when you were to do a carbon dioxide gas test, right? And this reaction we term it as less vigorous or less readily reaction. So that's the reaction of these three metals first. As you can see now, you should be able to spot a trend as you go down the reactivity series. You see what is happening to the type of reactions. Let's take a look at some of the other metals. For magnesium, when it is placed with cold water, it actually reacts very slowly. It still forms the magnesium hydroxide and hydrogen gas because there's a reaction, just that it takes place very, very slowly. For aluminium, there is actually no reaction. And this is rather interesting because aluminium is considered still not that unreactive a metal. And it's quite uncommon that it doesn't seem like it's reacting at all. In fact, if you look at your notes, it seems that it's not reacting throughout the entire all three different kinds of reaction. And this is actually because, right, aluminium actually reacts very well with the oxygen in the air, and this actually forms a layer of protective layer that we call the aluminum oxide. Aluminum oxide is actually preventing the rest of the aluminium from undergoing a reaction, and this is what it looks like. So you have the aluminium over here, and because it's being exposed to air once you take it out and it reacts with the oxygen, it actually forms this oxide layer at the top, and actually also at the edges, bottom. Actually it forms surrounding the entire structure, and it prevents any form of reaction from taking place. And for the last few metals, zinc, iron, lead, copper, silver and gold, it simply just doesn't react with cold water. Now let's take a look at a second reaction with steam. Steam is considered water at 100 degrees Celsius, and in this reaction it actually forms metal oxide and hydrogen gas. So this is actually a setup of the reaction. In order to generate the steam required for the reaction, what we do is we actually prepare a test tube in this manner. We actually have a glass wool that is soaked in water, and we actually place it next to the metal that we want to test and heat up the entire setup. Right. The purpose of heating is so that the water can produce the steam that we require for the reaction, and as the steam passes through over here in this direction, it actually reacts with the metal, and depends on the type of metal, there may or may not be a reaction, and the hydrogen gas that is being produced will actually eventually be channeled into this collection technique, right? The displacement of water. So let's take a look at what are some of the reactions. If you were to compare between cold water and steam, which one do you think is more reactive, cold water or steam? Steam is likely to be more reactive since it has a higher temperature to begin with, and this is really the case because you'll see that some of the metals that previously were not reacting with cold water, now they were able to react with steam. Rather, some that reacted previously with cold water, now if you were to put it with steam, the reaction becomes very, very explosively, such like potassium, sodium, calcium, and this should not be attempted in the school lab or actually anywhere else. For magnesium itself, if you have to react with steam, it's actually a very violent reaction and it gives off a very, very bright white glow. The product that's formed is actually magnesium oxide, which is a white solid, as well as a hydrogen gas. For aluminium, once again, there's no reaction because like what I mentioned just now, the aluminum oxide is just so persistent that it doesn't allow the rest of the aluminium to react at all. How about for zinc and iron? For zinc, it actually reacts readily with steam, and this forms a compound known as zinc oxide, which is interesting because it's yellow when it's very, very hot, and as it turns cool, it actually turns color to white. Iron also reacts, but it reacts very, very slowly. This time around, it forms actually a mixture of iron oxides, which we actually represent by this formula of Fe3O4, and it also produces hydrogen gas in the process. As for lead, copper, silver and gold, this time around, there is still no reaction. So as you can see, as you change from cold water to steam, some of the metal elements like iron, they are now able to react. But some of those that previously couldn't react, they still can't react over here at this point in time. Now, if you move on to the last type of reaction, which is the reaction with hydrochloric acid. So most of the metals can actually react with hydrochloric acid to produce a metal chloride, which is a type of salt, and hydrogen gas. So metal chloride is a type of salt. And this is actually a reaction that you have seen before. Like for instance, in the acids chapter, we actually added in the magnesium ribbon, then with the acids, you start to see a lot of bubbles, and we call effervescent, right? So this reaction is actually none other than the typical mesh reaction, right? Metal with acid give you a salt. In this case, metal chloride, because you use hydrochloric acid and you get hydrogen gas. So if you recap, we actually talked about this before in the chapter on acids and bases, that actually not all the metals are able to react with acids. In fact, that's when you first come across these mnemonics. Popular scientists can make a zoo in the lab, however cannot see gold. So we actually use the placement of H, however, to represent the acid, because acid gives you H plus ions, right? So all the elements that's actually at the top of H are expected to react with acid, with the exception of lead, whereas all the elements at the bottom below H, they are known to not be able to react with acid itself. So this is something that you have already noted in the previous chapter. But in this chapter itself, what we really want is for you to know how to actually describe the type of reactions that's going on and how to construct the equation based on that. So first of all, potassium and sodium should not be used in terms of reaction with, so there's a typo over here, in terms of reaction with HCl. Actually reacts very explosively and should not be attempted. Calcium reacts violently in this reaction. Magnesium, which is what you have done before in the school lab, it reacts readily. It also produces hydrogen gas, and this time around it produces the salt magnesium chloride. For aluminum, once again, there's no reaction because of the aluminum oxide. This time around for zinc, iron, there is a reaction. For zinc, it reacts readily. For iron, it reacts slowly, pretty much similar to in the case when you were to add them with steam. But the interesting thing is that this time around, lead can actually also react. However, the reaction is interesting because it's very slow. However, once it gets started, it stops almost immediately, and in fact, it seems like there's no reaction. Why is that the case? Okay, the reason is because you have actually learned this before, but when lead reacts with hydrochloric acid, it actually forms an insoluble layer known as the lead 2 chloride solid. So this lead 2 chloride pretty much acts like the aluminum oxide in the sense that it protects and prevents any further reaction from happening to the metal itself. And as a result, it seems like there's no reaction at all. So this is something for you to take note of. And once again, we see that copper, silver, and gold has no reactions again. But why does copper, silver, and gold seems to not react at all? Well, to explain this, you need to understand that these three metals are amongst the most unreactive metals of all in the periodic table. And as a result, it's very tough for us to provide a setup whereby they will actually react based on the reactants that we provide. So in this case, cold water, steam, and even your hydrochloric acid is not a reactive enough substance to actually allow this copper, silver, and gold to react with them, and hence no reaction takes place. And with that, we actually created the entire reactivity series like what we taught you in a few chapters ago. So based on the comparison of the types of reaction, we can actually see that potassium is the most reactive amongst them all, whereas copper, silver, and gold, in their order, they are the least reactive. We also see some variation, like how zinc can actually react with steam, but doesn't do that with cold water, right? So all these things are tiny details for you to read through, understand, and hopefully internalize, so that if a question comes up to tell you that, oh, can you tell me whether magnesium can react with steam, and you should be able to come up with the correct description of the type of reactions. Also, what if today I say that I found a particular element called X, right? And it's actually found over here. Say this X. It's actually between zinc and iron. And I have to ask you, can it react with cold water? How will you know this? You can only know this if you have your prior knowledge on whether zinc can react with cold water. So for instance, if you recall, in the previous set of notes, we say that zinc is actually one of the elements that cannot react with cold water, right? So iron also cannot react. So if you think about this, when you put this unknown element X directly below zinc in the reactivity series, can it still react with cold water? If zinc can't react, X most likely can't react, right? Because it's less reactive than zinc. So this is another application of your reactivity series. So in summary, going down the order from the most reactive to the least reactive, we have your potassium, sodium, calcium, magnesium, right? And this is their respective reaction with cold water, steam, as well as dilute hydrochloric acid. So you can see that hydrochloric acid usually brings out the most violent reactions amongst the different elements. Then you have your zinc, iron, lead, copper, silver, and gold, right? And you can see how some of them don't react with cold water, but still can react slightly with steam or very, very slowly with steam, or in the case of hydrochloric acid, how is it like? So in summary, this is how we derive the reactivity series. Now, we need to actually take some time to understand and remember the different types of chemical reactions when these different metals are being added to either cold water, steam, or hydrochloric acid. Try your best to understand and internalize all these different reactions in terms of how to describe them, how to construct chemical equations. That means you must know what kind of products come out, how to create a chemical formula, etc. Because those are actually the key ways to show your understanding of this chapter when it comes to the assessment. And once you're done trying to recap and redraw this thing, test yourself. Test yourself by trying out this chunk of consolidation table, right? You do not have to get everything right. It's not as if you can just do this immediately after watching this video and get 0 errors. What you need to do is, as much as you can, do not refer to the previous notes. But if you are stuck, feel free to refer to the previous notes, then come back and construct the chemical equations accordingly. But do take some time to use this summary table to recap as you prepare for your exams or tests. And with that, we have come to the end of the second video. So for the third part of the lesson, the teachers will actually carry this out in class with you because it requires you to do certain experiments or to watch certain videos together as a class. Thank you.